welcome to my channel. In this video is the continue of the problem 3 solution right after the previous one. So a brief introduction if you are if this video is the first video you watch. So we were solving this problem by trying to determine the acceleration vector and velocity vector, and to do that we have to first know the angular velocity and acceleration and the the radial radial velocity and radial acceleration. We did that last video, so this video we will combine the, that value we obtained to finally answer this question. Okay, let's move on. We will obtain it. So we obtain that theta at 5 seconds is 5 radians, theta dot at 5 seconds is 0.8 radian per second, theta double dot at 5 seconds is 0.08 radian per second squared. Okay, and also in the radial side, we have position of 0.7, velocity at minus 0.25, and then the acceleration at 0. Then, to determine the velocity vector, we then recall the vector of velocity vector formula. Then we substitute the r dot, r, and theta dot shown here. Finally, we are to obtain the first answer, that vector velocity equal to minus 0.25 in r direction and plus 0.6 in theta direction. Then we calculate the magnitude of this vector by using the square of the first term plus the square of another term and square root this value and get 0.65 meter per second. So we then want to know the direction. Okay, so firstly we look at the sign of each direction. So in r direction the sign is minus, right? So the vector should be in this side. Okay, then 0.6 is positive in theta, so that means not only in this the vector should point onto this side, but also it has to point toward positive. So the velocity we are looking at should be something like this. Okay, then what is the angle? Okay, then we have to draw some reference line, that's horizontal line here. Then we determine what is the angle. What is this angle here, which will be the angle will be the same as angle theta, right? Because if you look closely, this angle here, theta, will equal to this angle here, theta, right? So after 5 seconds, theta is 5 radians, or in the degree will be 286 degree. So we then try to calculate the angle beta 1. So beta 1 here, call it beta. Okay, beta 1. Okay, the beta 1 is calculated by the vector vector value here. So we get that minus 0.25 is the the distance on the axis r, which is parallel to here, right? So that means this distance should be 0.25. Okay, then on to the theta. Okay, that means this and this dimension here should be 0.6, right? So we perform the calculation on trigonometry. We get that tan of beta 1 equal to 0.25 divided by 0.6, and then beta 1 equal to 22.62 degree. Okay, so what left is that we have to refer the angle the direction we would like to tell, referring to the horizontal line. Okay, so then we know that this angle is perpendicular, right? So it's 90. That means the angle alpha 1 will be 200, 286, which is from this angle theta, plus 90 here, and plus 22.62 here, which is this beta 1, and in turn equal to 399.1. And if we look into a more simple angle, you will get that it will be on the quadrant number 1, because 260 will be start at origin again. So origin. So then 399 minus by 260, you get at 39.1 degree to be exact. That is the angle, sorry, that's direction referring to the positive x-axis. Okay, now let's look onto the acceleration. Okay, in the case of acceleration, we first have to recall the acceleration vector from your right hand side. So once we know every parameter we have to put in, we only need to substitute those and then compute the magnitude of each direction. Okay, in this case we got both in r and in theta in minus sign. So firstly we compute the magnitude by power of 2 summation, and then under the square root obtain 0.59 meter per second square. Now what about the direction? Okay, firstly we calculate the angle beta 2 of the angle that act onto the onto this small area, small triangle here. Okay, so beta 2 indicate the angle that act between the pink axis here and the acceleration vector. Okay, so why is located here and not here? Firstly, we have to look on the direction of the ER is in minus, right? So that means your vector has to be here. Then the theta also in minus sign. That means the acceleration cannot be from here, but it had to be here. Okay, so that means after we compute beta 2, we then do the summation of the angle from theta and 180 to this small angle, which is 35.31 degrees. Then compute all, summation all, we get alpha 2 equal to 501. Okay, so 501 is already past one round of rotation. So that means the angle will be let me around in quadrant number 2. Okay, if we simply calculate 501 minus 60, then we got ourselves let's see, 4141 degree, which will be on quadrant number 2 here. That is the acceleration vector will be on that direction. Okay, thank you so much for watching. I hope you understand how the magnitude and direction is being derived, and thank you again. I'll see you in the next video.